Hallmark Hotline, what is your emergency?
From Facebook, I don't want to butcher the first name, but from Mr. Apollo, the question is going to be, the semicircle of area 1250 pi centimeters is inscribed inside a rectangle. The diameter of the semicircle coincides with the length of the rectangle. Find the area of the rectangle.
Okay, I can take that one. So first of all, let's talk about, and then if you could just leave that up because I'm going to have to get this information. We talk about what inscribed means. In geometry, we're talking about, I'll give you an example that's a little bit more clear sometimes. If I want to inscribe a triangle into this figure right here, or into this circle, it really just means that some of all of these points, these vertices, are all touching the outside of the circle. So it's not perfect, but that's what we mean by inscribed. Oh, I don't know what happened there. So this would be a triangle inscribed inside of a circle. So when we talk about this, the question was saying the semicircle of area 1250 pi centimeters is inscribed inside of a rectangle. My first thought as William was explaining this or reading the problem was that it was going to be a circle with a rectangle inscribed. So that's something you want to be really careful about, right? Don't just automatically, because that's more often the case with these problems. Don't just automatically assume that. Make sure you're reading carefully. So the semicircle is inscribed inside of a rectangle. So I'm going to go ahead and draw a rectangle here. And I'm going to see if I can inscribe a semicircle inside of this rectangle. So what we're going to see is some of the points of this shape. Let me see if I can move this. Oh. Try that again. What you're going to see is like the points on this circle are going to touch exactly on, oh, I keep doing that. I can't move it once I've decided it's good, I guess. So we look at this, and you'll notice I am not putting the entire circle inside of here. And that's because the question said it was a semicircle inscribed in a rectangle. So if you notice here, this is the semicircle that's being inscribed. So I'm going to take a step back really quick and think through this problem again, because this is what you should be doing. What we ultimately want is to find the area of the rectangle. So in the bottom here, I'm going to write area of the rectangle. And I'm going to write the equation, length times width. It really helps as you're doing this to write all the equations that you know that relate all of these kind of parts here. The more complex geometry gets, the more formulas you have, the more important this becomes. So we said the semicircle of area 1250 pi. So I'm just kind of going back to the beginning. So you can think of area of a circle, should be familiar, is pi r squared. But then if you think the area of a semicircle, well, the area of a semicircle is going to be exactly half of that. So I'm going to rewrite this equation as 1/2 pi r squared. You're going to see a lot of these equations in geometry where you're not explicitly given the formula, for example, of the area of a semicircle, but you should know how they relate. So like I know a semicircle is half of a circle, so whatever the area is of my circle, semicircle will be half. Now, looking at this figure, I want to ultimately find the area of the rectangle. So what I'm going to do is I'm going to say, what do I need? I need the length, and I need the width. And then I have to ask myself, how do I find these things? So I'm going to put this in green so it's clear that it's the length here and the width of the rectangle. Okay. So if we're saying a couple things, and I didn't even read this part, the diameter of the semicircle coincides with the length of the rectangle, and that's pretty important. All that's saying is this diameter here, and I'll erase this, it's not messy, is the same as the length of the rectangle. It's really just emphasizing that this rectangle is going through the diameter of the circle. And again, you'll notice in geometry, it's really important to note those key points because a lot of geometry is about not making assumptions. So we look at this, I would think, well, in order for me to know the length, I need to know the diameter of the circle. And in order for me to know the width right here, I'll do this in blue, well, I need to know the radius because the width corresponds to the radius. So what I can do is, William had said that the area of the semicircle was 1250, so I'm going to replace this with 1250. And then what I'm doing is I'm saying now I have an equation that I can solve because I have one variable in it. Oh, and I forgot one part. It's 1250 pi. It's not just 1250, which actually sounds like it makes the problem harder because you're throwing pi in there, but it actually makes the problem a lot easier. When I originally heard this problem, I thought, oh, I'm going to need a calculator. And now that I know that pi is the area, I know that I actually don't need one. You'll see why. So when we're solving this, we're going to say, I'm solving for r right here. So I need to get rid of all this extra stuff here. I need to get rid of the 1/2 pi. I need to get rid of the squared. So what we're going to do is first divide by pi. And this is why I say that I'm actually pretty happy that the area had pi in it, because you're going to see how it works out. It's going to cancel it out, and I get rid of that kind of, I want to call it an ugly number. Like pi is actually kind of a beautiful number, but when you're doing
rational number, if we're getting really technical.
Right.
But
when you're doing calculations, you don't really like doing them with pi because you have to eventually use your calculator or leave it in kind of a weird form.
Yep.
But this works out nicely. It cancels out. So I'm going to be left with 1/2 r squared equals 1250 now. And then to get rid of this 1/2, we're going to multiply by its reciprocal on both sides. All right, because you should remember when you have fractions, when we multiply something by its reciprocal, it becomes 1, and effectively it cancels it out. And then we're left with r squared equals 2 times 1250, which is 2500. And then the last thing you need to do is, because you're solving for the radius, not the radius squared, square root of each side. You get a radius equals 50. And then again, I always like to point out, mathematically it's plus or minus 50, but we're talking about a radius. You cannot have a negative radius in a circle, so the negative is irrelevant. And just a quick tip, if you want to know how to do this in your head really quick, the square root of 2500, if you know the square root of 25 is 5, then you can just take out one of the zeros and it's 50. So here's what we have. We have a radius of 50, which means that, look, that my width is 50. We still need the length. Well, if the radius is 50, it means that this is 50, this is 50, the diameter is 100. So we got to know all of those relationships in order to figure this out. And now we plug this in and we get the area of the rectangle equals, I wrote this equation down here for two reasons. One, it's often easy to forget what you were solving for. So if you write it kind of in the bottom corner, you can quickly look and be like, oh yeah, I was solving for area. Then check your problem and make sure that's what you're doing. It's going to have a length of 100 and a width of 50, which is going to be 5 and 3 zeros. And I don't know what the unit was, so I'm just going to say units squared. So that's the idea. We need to know a lot of these properties, and we need to be comfortable manipulating them, moving them around, and applying them in sometimes odd scenarios or odd problems. I don't know. A lot of times my students will give up when they see this.
Yeah.
But if you draw a model and play around with it a little bit, a lot of times you'll find that the answer actually comes out pretty nicely.
And coming up with the equation a lot is also the hard part.
Part of
if
the
you
challenge.
can get an equation, then usually you can get there.
Yeah.
So yeah, I don't know. I've
And
noticed
then-
that with students.
Right. Just think about like semicircle. I don't have an equation for that, but I do have the equation for a circle.
Right.
Well, how is a semicircle related to
Relationships.
path? Right. So that's a
Yep.
lot of what these equations are about.
Very true.
Yeah.